All right. Good morning, boys and girls. Wow, good morning. We're going to start our math lesson this morning. We have been covering and talking about decimals, fractions, and percentages. And today we start a new unit. And actually, this class is going to be a review, a refresher of some of the things that you already know. And we're going to be talking about shapes and perimeter, understanding shapes and perimeter. I would like you to look at this shape that I have here. Have you seen it before? You haven't seen that before? What is it? Anybody knows how you call that? Huh? It's actually a decoration. It's called an origami. It's the art of folding paper into decorations. And what do we notice? Can you see anything here of what you know already in mathematics? We have shapes, right? It is made up of different shapes. So you actually use you create a three-dimensional decoration, but actually it comes out of two-dimensional shapes. What are some of the shapes that we can see here?
Rectangles.
We have rectangles. What else? Triangles. Squares. So we have all these kinds of figures and they're all colorful. So it is actually a decoration that is made creating this beautiful art. Well, today we're going to focus on shapes. Now, we're going to be looking at starting the broad topic of geometry. And in geometry, we study shapes. We study the sizes, the shapes, their position, and different dimensions. But we will be zooming in one specific topic known as polygons. So, can anybody tell me what are polygons? Anybody from the class knows what a polygon is? Come on guys, let's participate. Don't be shy. Yes?
Shapes with sides that are
Yes, it's about shapes.
different.
Shapes that are different. Yeah, more or less there. Good. Anybody else want to share something else? What are polygons? Come on guys, you should know this way from back. It's under 4, it's under 5. Yes?
Shapes that have different sides or edges.
All right. That's part of it. Anybody wants to add to it? So, let me show you. Polygons are flat shapes with straight, fully closed sides. So it is an enclosed shape with different sides. And so that is what we want to review and look at today. That's why I gave you the picture so that you could have an idea what is it. It's an enclosed shape with different sides. And so we want to have a close look of this shape as well as their properties. And when we look at their properties, that is going to help us also to find the perimeter, which we are going to be looking at later. So within your tables, that is what I want you to, we are going to start a hands-on activity this morning. And we're going to use the toothpicks that you have there on your tables. And we are going to create these shapes, specifically looking at those that have from 3 to 6 sides. From 3 to 6 sides. So I want you to gather there as a group, pull out the toothpicks, and we are going to create some shapes. So this is what you need to do. Can I have your attention? Yes, you guys are going to be creating polygons, constructing polygons using the toothpicks from 3 to 6 sides. So it's a 3-sided polygon, a 4-sided polygon, a 5-sided polygon, and a 6-sided polygon. And we're going to be using the toothpicks to construct these shapes. So let me give you the following 5 to 6 minutes, and I want you to start constructing these polygons using the toothpicks. And I will be going around checking on the polygons that you're constructing. So let's take this time now. little bits in the middle. Remember, it's an enclosed shape. So just with size around. So I see you guys coming up with those beautiful constructions there. Huh? Right now, I'm not. I'm showing the name. Alright guys, so you have constructed your polygons. Remember, a polygon is, what's a polygon? A flat shape with enclosed sides, okay? So that's what a polygon is. And depending on the number of sides of your polygons, that's the name it gets. So, can I hear the names of some of the polygons that you just constructed? Let's do it in order. Let's begin here.
We have triangle.
We have a triangle right here, a rectangle here, a square. You guys constructed a parallelogram, and that's part of the parallels are part of what? Which types of shapes? A parallelogram is a quadrilateral that has how many sides? 4. So we have parallelogram. You guys here? Huh? Well, I think I didn't ask for an octagon because an octagon has how many sides? 8 of them. So I did not ask for an octagon, but yes, octagons can also be constructed. They have 8 sides. I asked up to 6 sides, and a 6-sided polygon is a
Hexagon.
huh?
Hexagon.
Hexagon. The word hexagon. Hexagon. That's the term we use for a 6-sided polygon. Hexagon. And then the 5 sides is a pentagon. And all the ones that are 4-sided, they are all called quadrilaterals. And within quadrilaterals, we have squares, and we also have rectangles. And within squares, we have many more examples. And then within rectangles, the same thing. Like he says, a parallelogram, but a parallelogram looks much like a rectangle. And I don't know if the shape you showed me here is a parallelogram. What do you think it is? The other sides are the same size. That one is known as a rhombus. That one is known as a rhombus. Okay? Alright guys, so you have constructed different polygons from 3 sides up to 6 sides. Now I want you to concentrate on the following, and within your group discuss. We have named the shapes. Now I want you to come up with at least 2 properties for each shape. Discuss within your group, and I want you to come with at least 2 properties for each of the polygons that you have constructed using your toothpicks. These are the things that you need to think of. Look at all the sides, look at the angles, think of whether the sides are equal or different in length, and then in the next 3 minutes we are going to discuss some of the properties of your shapes. Please don't start doing something else that I didn't ask you to do. Keep your different shapes that you have constructed, and within your group discuss. discuss at least two facts, two properties of the different polygons that we have constructed. Remember, you're looking at the number of sides, the angles, whether they are equal or not. So go shape by shape. Let's look at the three-sided. Let's look at the triangle. Think about its properties, at least two of them. Look at the squares, the rectangles, and also let's write some of the properties, and then we are going to share. What do you think about it? So, are we looking at? Let's concentrate on this. So you're looking for a square. What have you found about the square? All sides are the same. All sides are the same length. Was it corner? How do you qualify it? No, you don't know the edges. The edges will be the sides. There are two vertices. One corner is vertex out, plural is vertices. And what about the angles? Okay, they're the same, but I'm correct. Okay, so guys, can you tell me about the pentagon? This pentagon that you constructed, what can you say about it? Has 5 sides or equal sides. And what do you think? Huh? Straight and equal what? Yes, the shape is an equal shape. What do you think about the angles? Do you think all the angles are the same? Some angles might be different size, right? What about your hexagon?
Sí, acá estoy hablando de una razón, porque me viene
What about the vertices? The vertices are recorded. Okay. Alright, can I have your attention, guys? Have you finished working with other properties? Or do we still need more time? Alright, so let's listen. Let's come together here. And I'll be asking this table here to explain the properties for the triangle. The three-sided polygon. Let me hear from you guys. Yes?
The triangles are equilateral.
So the triangle that you constructed is an equilateral triangle. Why would you call it an equilateral triangle?
Because the sides are the same and all angles are equal.
All the lengths of each side are the same in size as well as the angles, right?
Yes.
Good. So those are two properties for triangles. And this is the specific triangle that you constructed because I didn't see you constructing any of these, of the rest that we have here. But an equilateral triangle, we have the length of each, the length of each of the sides is the same. And we indicate that by putting this small dash on the sides. if you look at the angles, they are all the same. So 3 equal angles, 3 equal sides. Anybody knows what's the size of each of the angles? Think again. 60 degrees. Why would you say it is 60 degrees? Either this group or anybody who knows the answer can raise his or her hand and tell me. Yes? Do you know why each angle is 60 degrees? Anybody? You are so quiet today and you always are so eager to participate and now you don't want to tell me? Come on, you need to tell me. Anybody knows?
Because those sides are placed in
Okay. If you say that these angles are, each one of them is 60 degrees, when you put all of them together, what does it add up to?
180.
180, exactly. One of the properties of triangle is that the sum of the interior angles is always 180 degrees, and therefore each of these angles will be 60 degrees. So there you have this special triangle. You could have also constructed the isosceles triangle. Those who, I think almost all of you did this, what do you need to add in order for you to have an isosceles triangle?
add more length to the sides, to two sides and one side will be short.
Okay, so that means that these two of the sides will have a longer length and they will be the same length, while one of them stays shorter, right? And that's what an isosceles triangle is. Two of its sides are equal in length, while the other one is different in length. And it only has two angles being the same length. Yes, and Alexa? Two of the angles are the same in size. Then we have the scalene triangle. Can anybody tell me something about the scalene triangle?
The sides are, the length is not the
Let me
same.
hear from this side and just wait. Let me hear from this guy. Yes.
None of the sides are even.
Okay, none of the sides matching length. They are different lengths. So when you measure the length of this side, it's going to be different from this and from this one. And then we have the right angle triangles, which are 90 degrees, and then so the other one is the right angle isosceles triangle, which has a 90-degree angle, and the other two angles are the same in size. So if you were saying, okay, the triangle is 100, when you sum up all the angles, the interior angles of the triangle, they are equal to 180 degrees. And since this is 90, what do you think these two angles will be?
60.
Are you sure?
No, I'm
180.
If this is 90, and then these two angles together with the 90 should add up to 180 degrees, what would be the size of each of those angles? Huh? Come on, let's do that mental math.
45.
45 degrees. How did you find that out?
I divide the 180 by 3. No,
190.
I 90.
Not really.
No.
You already have 90.
I subtract the 90 from the 180 and then I divide by 3. By 2.
Very good, exactly. Good way of solving it. See?
Yes.
That's why I would say mental math is good, because whenever you don't have the pen and paper, you can easily solve it. Correct. Good. So we have stayed there with the properties of triangles for quite some time. Let's look now at the quadrilaterals, and I want to focus specifically on squares. Let me ask that table over there. What are the properties that you came up with about squares?
The square has 4 equal sides and it's a quadrilateral.
Okay, 4 equal sides. Correct. Can you tell me about the angles? Bernabe, what do you say about the angles? Hmm? Vamos, Bernabe, say something.
Yes.
Has 2 angles?
No.
How many angles? 4 of them, and they are all?
They are unequal.
They're all equal. So, do you know what's the size of each angle in a square? Let's have another group help.
90.
90 degrees. How did you come up with that number? This is 90, that means this is 90, 90, and 90. How did you come up with that number?
When you add 90 with that, and 90, you get 100. You get 360.
Yes? 360 degrees. Because the interior angles of a square add up to 360 degrees. 90 plus 90 is 180. And then 90 plus 90, another 180. 180 plus 180 gives you 360 degrees. Yes, so sides and angles, four sides, four angles. The sum of angles is always 360 degrees. And you said that a square, all sides are equal in length. Now let's look at the next one. Let's have the back table over there. Tell us about the properties of rectangles.
Opposite sides are not in the same length.
Are not or are? Are the same length. Opposite sides, you mean this side with this side is the same length. And if we look at the width here, opposite, they are the same length. What else?
They have 4 sides.
Yes, you just said that. Four sides, 1, 2, 3, 4. And you said that the opposite sides are equal in length.
Are the sides are equal? Are the angles are equal?
Okay, all these angles are equal in size and the angle size is
90 degrees.
90 degrees, similar to the
Square.
square. They up to 360 degrees and all angles are 90 degrees. So rectangles then, opposite sides equal, all angles are 90. Now let's move on to pentagons. We're going to give that to the next table, Eric's table. Tell me about the pentagons. A pentagon has how many sides?
5.
5 sides. So, what's the property? If you're talking about the sides, a pentagon has 5 what?
Equal sides.
5 equal sides. If it is a regular pentagon like the ones you constructed, remember, you should still have there your constructions. Don't mess them up because that will help you have a visual representation of what we're looking at. Remember that all the little sticks that you have there are the same length. So when you took 5 of them to construct your shape?
Yes.
That means that you constructed a regular pentagon, so all the sides are equal in length. How many angles?
5.
How many?
5.
5 angles. And you were saying a number there. You were saying a number? What was the number you were saying? Do you think that the pentagon will be 360 degrees like the...
No.
No?
No, maybe 180.
180? A triangle is 180. But remember, you're adding more sides and there are more angles. Okay, so here it is. The sum of angles is always 540 degrees. We're going to go deeper into this property later on. We are interested in the size, the number of sides right now. So let's look at regular pentagons, like how we just said, have all sides and angles equal. And in this case, they add up to 540. While we also have irregular pentagons that do not have the same length in size and angles, they differ. So we have the regular ones and we also have the irregular ones. The ones you constructed are the regular ones. And finally, let's look at the hexagons. So let's hear this table.
The hexagon has 6 sides. And they have 6 equal sides.
And they have 6 equal sides.
They
Okay?
have 6 vertices and 6 angles.
6 vertices and 6 angles. Okay, very good. So there we have the properties. The sum of angles is always 720. As you keep moving higher into the size of the number of sides of a polygon, the sum of angles keeps increasing. So regular hexagons, what Aaron mentioned, have all sides and angles equal. And the irregular hexagons do not have equal sides. So there we have the properties then of these different polygons. Why do you think it is important to know the properties, especially the sides, in this case the sides of the different polygons?
So we can find out the angles or the perimeter of every shape.
Very good. So there we go again. Jaden giving us a great answer with respect to the size of polygons. They are directly related to us being able to look for perimeter. And now that you mentioned perimeter, what is perimeter? Let me hear somebody back there. Yes.
The distance around the shape.
The distance around a shape. And in this case, the distance around the different what? No, what have you constructed? What do you give? What name you give shape? What name do you give? Polygon. Remember, a polygon is an enclosed shape. So the perimeter of a shape is the distance all the way around the outside. So if we take the whiteboard as an example, and if I want to walk or measure the perimeter of the whiteboard, and I take one of the sides as this reference starting point, let's say here, I must measure or walk this side, go all the way up, then come back, and finally end at the starting point. And that's the perimeter of the whiteboard. And what shape is this? A rectangle. Okay, so based then on that, based on the properties of each polygon and the number of sides that you have mentioned, I want you to come up with ways, with formulas if possible, how you would calculate the perimeter of each shape, being the triangle, the square, the rectangle, yes?
A squared plus B squared equals C squared.
Oh, you're talking about something else there. We're talking here about the perimeter. Just, so, could you do that, please? Could you discuss within your tables and look, find how you can calculate the perimeter of each of the shapes? Discuss it first with your table, and then we are going to hear you. Take into consideration the properties. Remember, some properties differ. The properties differ whenever you move from one polygon to the next. If you're talking about triangles, squares, rectangles, pentagons, or hexagons. So discuss what would be a general formula we would use, and other special formulas for specific polygons that we can use to find the perimeter of each of the shapes. Based on the properties of your shape.
So 5 sides, so they have
So,
5
do we have a name for the size of the rectangle?
Yes, 5 tests, so they have
What's the longer side? How do you got the longer side of the rectangle? Up the length, and then the shorter side of the rectangle. So maybe you want to say length times 2, two lengths, and then width times 2. That will give you a formula for okay, guys. Let me hear from you. You haven't done the triangle one? So, have you concentrated on the triangle? Because I will be asking you about the triangle. And which one have you done the triangle? So at all the sides, if it is an equilateral triangle, all the sides are the same. Remember, I want you to focus on property as well on how that we can find the perimeter. So your general formula will be add up the sides. And what about this specific triangle, which is an equilateral triangle? All sides the same length. What would you do? What other way can you find the perimeter? But that's one way. That's a general way too. Times the length of one side times the 3 sides, correct. So it's going to be like 3 times side or 3s. So that will be a formula to find the equilateral. What about the pentagon, the regular pentagon? Guys, can you tell me about the hexagon? Tell me about the pentagon.
This. So how do you decide the perimeter of the
perimeter, measuring the length of the sides, and adding sides. If it is a regular one, how is going to find it? If it is a regular pentagon, remember a regular pentagon, all the sides are similar. Remember we're looking at the property. How much? How much do you want to divide by? We're using partial, so it's 5 like this. So how much that you need to do in order for it to function? Add on the sides. Right, so it's S, you're taking S with this. Yes, S plus S plus 10%. That's why I want to 5 times the length of one of the sides, right? That's what I want to do. Would you do something similar for the hexagon? If it's a regular hexagon? Just like for the hexagon, it's going to be correct. All right, everybody. Let's reconvene together here and let's look and review the different properties. So, what's the general formula that we can use to find the perimeter of any of these shapes that we have discussed this morning. Yes? No? Huh? No, I'm talking about all of them. What's the general formula that we can use?
All of the sides.
Okay, add all the sides. And see where the property, knowing the property of the number of sides of each polygon is important. Because how would you know how many sides will you add if you don't know how many sides that specific polygon has? So it is very important that, so there is a relationship between the number of sides of your polygon and what you will be adding. So that's the general rule, right? You are going to be sum of all the side lengths. That's the general formula. But then we can use some specific formulas for other polygons. For example, we were discussing about calculating the perimeter of the hexagon and the pentagon, also the square and the rectangle. You could have a specific formula for those there. So for regular polygons where all the sides are equal, the perimeter can be calculated by multiplying the length of one of the sides times the number of the what? The size of your shape. Alright. So we're looking at triangles. We looked at triangles and their general formula is, if we label this A, B, C, that means that to find the perimeter, and we're going to use the letter P to represent perimeter, all we need to do right is add what? A plus B plus C. And because this is a special triangle known as an equilateral triangle, all the sides are equal in length, we could also say that perimeter could be, anybody? S times 3 or 3S, right? Meaning that you will multiply 3 represents what? The 3 equal sides, and S represents the length of one of the sides, and that will also give you the perimeter of this specific triangle. Now for this one, you will have to go with the general formula where you're going to be adding A, B, C. But later on, and we're not going to focus on that today, we will find out that knowing the property of this specific triangle, which is an isosceles triangle, will be easy for us to work with other parts of, to calculate, for example, one of the sides of the triangles. And we will do similar with the triangle that all the different sides are not the same in length. We could follow the general formula that we have here. So, can you please have this as part of your notes in your exercise book if you haven't written it? You can write this formula for triangles. The general formula would be then add on the sides. But if it is an equilateral triangle, you can use this formula because comparing it with the properties which all sides the same length, we can use the formula 3S. Okay, moving on. Let me hear for the squares. Let me ask this group, this second table over here, Royland's table. What did you discuss could be the perimeter for a square?
For a square, the square has the 4 equal sides, and
So
so
it
you
will
add
be
the 4
side
equal
plus side
plus side
plus side plus side. Is there another way how you can calculate the
Yes,
perimeter of a square? Yes?
by times four.
By times in what? 4. Where did the 4 come from?
For the 4 sides of the
4 equal sides, right? So we can use 4 and then S to be used to represent the length of each of the sides. For example, if this was 5, then it's going to be 4 times 5. And then you can shorten the step to find the perimeter of the square. Okay, let's move on to rectangles. The back table there, Amira, Helber, and let's begin with the general formula which would be,
Length times 2 plus
also you said length times 2
plus
plus
width
width times 2. We can put this in parentheses, right? And why did you say length times 2?
Because there is 2 lengths and 2 widths.
Okay, 2 lengths and 2 widths. And the 2 lengths are same in size, right? The measurement is the same, and the 2 widths the same thing. That means that we can simplify this as 2L plus 2 width. And this comes from, if we use a distributive property, we end up with 2L plus width here. I don't know, do you remember the formula now? If you have seen it before? Perimeter for a rectangle is 2, in parentheses you have length plus width. And then you can use the distributed property 2 times L will give you what you guys came up with, the 2 lengths, and 2 times width will give you the 2 widths for the rectangle. So there we have the formulas for how we can arrive at the perimeter of our rectangle. All right, let's move on. Pentagons. Let me ask Eric's table about pentagons.
Side times 5.
Okay, why do you say psi times 5 or 5s?
Because the 5 represents the 5 sides of the pentagon, and the S, the measurement of each side.
Okay, but this formula work with this irregular pentagon? No?
No.
This is, you can use this formula if the sides of your pentagon are all there,
Equal.
same length. In other words, this should be a what? What type of pentagon? No, equilateral is triangle. We're talking about the pentagon. Has to be a what?
5 sides.
Yes, but if all the sides are the same length, you give it a special name. Huh? No. We went over it already. Regular, correct. This is a regular, very good. This is a regular pentagon. So you can use the formula 5s because you know that the measurement of all the sides are equal in length. So you can use that formula. But not so for the irregular pentagon. What would you need to do here? If it's an irregular pentagon, what would be the perimeter here? Huh? Yes, you will have to use the general formula, which is going to be at the other side. So it's going to be S plus S plus S plus S plus S, right? Okay. Finally, let's look at the last one, which is the hexagon. What can you tell me about the hexagon, guys? How many sides? 6. So what formula can we use for this one? If you relate this formula to the previous one that was given, that was 5, it was a regular pentagon, this is 6 sides, and it is also a regular, in this case, a regular hexagon. And looking at the properties, it has 6 sides. So what would be the formula you would use here?
6 times S,
6 times the size or 6s, right? You could use that formula to quickly get the perimeter of this. And then let me remind you, perimeter is the distance around the shape, not the space. We're not talking about the space inside. If it is an irregular pentagon, hexagon, then you would have to use the general formula, which is adding up all the sides. Great, so we have reviewed then. Go over the different formulas that we can use when we're working with the perimeter of these different hexagons. We have done quite a bit of formulas. This information we're going to be using it in our next class, in which we're going to get into the real calculation of perimeters of these different shapes that we have discussed today. For now, I want to end this lesson by you guys writing a reflection of what we have covered and by answering these 3 questions that I have here for you. And this is individually. Reflect on the following questions. How did building the polygons help you understand their properties? That's one. Remember, we started building the polygons at the beginning with these little 2 big sticks. The next question. How does knowing the properties of a polygon make finding its perimeter easier? Remember that we use the properties, the number of sides of the polygon, whether they were equal or were they different in length. And then, can you think of a real-life example where understanding polygons and perimeters would be useful? We find perimeter of different polygons because in real life we use them a lot. So let's conclude our lesson by doing this exercise. Answer these 3 questions, and in the next 5 minutes, I will hear a few of you only. And with that, we will conclude our lesson. So take your time and look at the question, analyze it, and then answer. conclude our lesson. All right. Let's look at the questions and see if I can get some insights from you guys as to what you have written or reflected on the different questions. The first question says, how did building the polygons help you understand their properties better? Remember at the beginning of the lesson I asked you to take the toothpicks and build these polygons. Can I hear from any volunteers what is it that you gained from this experience? Yes, Wayland.
It helps understand by showing if all the sides are equal and shows how many sides the shape has.
Okay, very good. You're able to get real experience, right? Look at it visually, you can manipulate it, and you can actually have a sense of the different size angles and angles of the different polygons. Anybody else has something to say about the same question? Yes, and Daphne?
Polygons helped me understand better. During the process of building the shape, I was able to understand and learn about, for example, the square has 4 sides.
I was able to understand about the size and everything about the shape.
Okay, very good. So you're able to actually see the number of sides, whether they are equal in length or whether they are different, right? Very good. Thank you for that, for participating. The second question, how does knowing the properties of a polygon make finding its perimeter easier? How does knowing the properties of a polygon make finding its perimeter easier? Any volunteers? Yes, Jacob.
It makes it easier because knowing the properties helps me not to make a mistake whenever solving to find a number.
Yes, say again.
It is easier because knowing the properties helps me not to make mistakes whenever solving or finding the value.
Okay. In what way does it help you not to make a mistake?
And not knowing what the angle is equal to, or not knowing how the right
Okay.
length.
The length of the sides, right? Yes, great. Okay. Somebody else? Let me have one more person to share on that. Yes?
Knowing the property of a polygon helps by showing how to add it easier and finding the perimeter easier.
Okay, we didn't quite hear what you said. Just say it a little bit louder.
Knowing the properties of a polygon helps by showing how to add it easier and show you how to find the perimeter easier.
Okay, so knowing the size, now in the size of the length of the size and knowing how many sides helps you to find the perimeter easier. So you see how knowing the properties will help you find the perimeter easier. So the last question, and then we'll finish here. Can you think of a real life example where understanding polygons and perimeters would be useful? Can you think of real life situation? Yes.
When doing a squared table, we need to find the length of the length of the sides and also the area of the table that we're making.
Well, area is kind of different because area is about the surface that it is occupying. But yes, if you want to measure a length, you want to know the amount of lumber wood that you want to buy, then that perimeter might be useful there. Let me hear somebody else in another real life situation. Okay, that relates to the polygons, right? If you have the idea of what a square is, you will be able to do that. But how does it relate to perimeter? Think of ways how you could use it out in real life. Yes, and
Drawing a plan for your house.
okay, drawing a plan for your house. Yeah, that perimeter, knowing shapes, knowing polygons is crucial here. So architects and others people who build houses and things like that, they have to have a good knowledge of polygons and perimeter and stuff like that, so they can be able to come up with the plans.
Whenever we build things,
Yes, in building, yes. Fencing a garden, right? Like if you want to fence the school compound, you will have to know that as well. Okay, so guys, thank you very much for participating in this lesson, and I hope that this information is going to be useful for our future lessons because we will continue going to the actual calculations of perimeter as we continue with